Okay, the first thing we're going to look at is how to find a least common denominator. We're going to start with regular fractions and then move into rational expressions with polynomials. So when we're finding the least common denominator for just regular fractions, then what we're really looking for is the least common multiple for the two denominators. The least common multiple for 3 and 2 is 6, so the least common denominator for those two fractions would be 6. That one was easy for us to do in our heads because most of us know the multiples of 3 and the multiples of 2. But if I gave you bigger denominators like 14 and 49, some of us don't know the multiples of 14 and 49 right off the top of our heads. And so rather than listing those multiples, because that's not super easy to do either, we can use this method to find the least common denominator. And this is what we'll use as we move into polynomial denominators as well. To find the least common denominator, you can get the product of the highest power of every different factor that you see in the denominators. So we're specifically looking at the factors for the denominators. So 14, if we factor 14 to prime numbers, it's going to break down to 7 times 2. If we factor 49 down to prime numbers, it's going to break down to 7 times 7. Now we want to write that. I like to put my numbers in order. That's called my prime factorization for 14. For 49, I want to write that with exponents, 7 squared, and you'll see why in a minute. Because when I calculate my least common denominator for 14 and 49, I'm going to follow this here that says to find the product of the highest power of every different factor. And by every different factor, I'm talking about looking at these factors right here. So I see we have factors of 2 and we have factors of 7. And so the highest power of 2 that we see is just plain old 2. And the highest power of 7 that we see is 7 squared. And it said to find the product of those, so that means to multiply. So 7 squared is 49, and 2 times 49 is 98. So the least common denominator for 14 and 49 is 98. Now we can use that even if we have multiple fractions. Let's say we have 3/8, 7/10, and 4/15, and we're looking for a common denominator for 8, 10, and 15. Again, we could list multiples of these numbers if we wanted to, or we can use this method that we just learned. So let's break the denominators down into prime factors. 8 can be broken down to 4 times 2. 4 is not prime though, so we have to break it down further, and then we end up with 2 times 2 times 2. Or for 8, that's 2 to the third power. 10 can be broken down to 2 times 5. Those are both prime numbers, so that'll be 2 times 5. And 15 can be broken down to 3 times 5, and those are both prime numbers. So we'll write that down here. Now, my least common denominator, again, will be the product of the highest power of every different factor. So you see in our list of factors for each denominator, we have 2's, we have 3's, and we have 5's. The highest power of 2 that I see is 2 to the third power. The highest power of 3 that I see is just a 3. And the highest power of 5 that I see is just a 5. So if we multiply all this together, we'll find our least common denominator. 2 to the third power is 8 times 3 times 5. I don't know, let's see, 8 times 3 is 24, 24 times 5. If you don't know that off the top of your head, it might be easier to go 8 times 5 is 40, and 40 times 3 is 120. Multiplication is commutative, so you can do it in any order. So keep that in mind, and that'll help you be able to do that with some mental math. So the least common denominator for these three fractions is 120. Now, as we get into polynomial denominators, let's see how we apply this rule. Alright, if my two rational expressions are 5 over 3x squared z and 7 over x to the 5th y to the 3rd, and I'm looking at these two denominators, trying to find the least common denominator. Well, my number part, my coefficient in the denominator here is 3, here it's a 1. Well, the common denominator for 3 and 1 would be 3. Alright, then we're going to take the highest power of every different factor, and those variables, we're looking for the highest power of every different variable that we see. So we see x's in the denominator, we see y's, and we see z's. So the highest power of x that we see is x to the 5th. The highest power of y that we see is y to the 3rd. And the highest power of z that we see is just z. So this is my common denominator for these two rational expressions. Alright, let's look at another one. Alright, if I have 1 over 10a cubed b squared and 1 over 15 a to the 4th bc, and I'm looking for my least common denominator. I'm going to look at my coefficient parts first. I have a 10 and a 15. I need to get a common denominator for my 10 and my 15. You can break them down to primes like I did earlier if you want to. 2 and 5 for the 10 and 3 and 5 for the 15, and you would need one of each of these because they're all to the first power, so you'd need a 2 and a 3 and a 5 in your common denominator. So 2 times 3 times 5 is 30. You could also find that by listing multiples of 10, 20, 30, 40, etc., and multiples of 15, and the first one you get to that they have in common would be the least common denominator for the coefficient part. And then for the variable parts, that you're going to use the highest power of every different variable that you see. So I see we've got a's, b's, and c's. The highest power of a that I see is a to the 4th. The highest power of b that I see is b squared, and the highest power of c is just a c. So that would be my least common denominator for that pair of rational expressions. Okay, now those were monomial denominators. Let's see what we need to do when we have binomials or trinomials in the denominator. What if I have a plus b over a squared minus 25 and 1 over 2a minus 10? Okay, if you have binomials or polynomials with more than, I guess I should just say if you have polynomials with more than 2 terms. Then you need to check to see if you can factor the denominators before you try to name a least common denominator. Yeah, I'll leave it that way. I should have just said if you have polynomials with 2 or more terms. Okay, so this one has 2 terms, this one has 2 terms. These are binomials. They can both factor. This binomial is difference of squares. It factors to a plus 5 and a minus 5. This binomial has a greatest common factor of 2 that we can factor out, which will leave a minus 5. So the least common denominator for these, we do it the same way. It's going to be the product of the highest power of every different factor. Well, I have a 2. I've got to put that in my common denominator. I have an a plus 5, and I have an a minus 5. We only put one a minus 5 in the common denominator because that's the highest power of a minus 5 that we see. We have an a minus 5 to the first power here and an a minus 5 to the first power here. So the highest power of a minus 5 that we see is a minus 5 to the first power. So we only need one in the common denominator, same with a plus 5 and same with the 2. So this whole thing will be our common denominator there. Let's look at another one like that, or similar to that. X minus 5 over x squared minus 2x, and 1 over x squared minus 4x plus 4. Okay, again, we've got a binomial and a trinomial, and we want to factor those if possible. This binomial has a greatest common factor of x, so we can factor out an x, and that will leave us with x minus 2. Here we have a trinomial with a leading coefficient of 1. We're looking for what multiplies to get positive 4 and adds to get negative 4. That would be negative 2 and negative 2. Now it's important that if you have factors that repeat like this, that you write it with exponents. Okay? Because when you go to write your least common denominator, remember we want the highest power of every different factor that we see. So I see that we have an x. We're going to need an x in our least common denominator. And then here we have an x minus 2 to the first power, but here we have an x minus 2 to the second power. So we're going to need x minus 2 to the second power in our common denominator. Okay, one more. We'll have 6 over x squared plus 5x minus 14, and 8 over x squared minus 3x plus 2. Again, we've got trinomials in the denominator. We want to see if they can factor before we look for a common denominator. Here we have a trinomial leading coefficient of 1. What multiplies to get negative 14 and adds to get positive 5, that would be positive 7 and negative 2. Here, what multiplies to get positive 2 and adds to get negative 3, that would be negative 2 and negative 1. Our least common denominator then will need highest power of every different factor that you see. I see an x plus 7. I see an x minus 2, and I see an x minus 1. So this would be my common denominator.